Okay, class. This is going to be an extension of things we've learned before as far as linear functions. And I found this app that might help everyone kind of visualize a little bit more. And so I found an exercise that we can do with this. We talked about before functions are basically taking an input, entering it in, and then finding the output. And so this is what this app kind of does. You have the input here, the different places where you can manipulate it, and then the output. And then it also shows us a graph. And so we can graph these linear functions. Everything we're dealing with, again, is going to end up graphing into a straight line. And so if we go to our homework, that assignment that I got, which is right here, if everyone can get that out, we will look at this and go through a few. Okay. So the first one is x plus 2, right? F of x equals x plus 2. So that is the function of x. So we can come down here and we can find, oop, I went overshot it. There we go, the plus, and we can bring a plus 2 in, and we can move that up into the input output. So that's going to be the back end. And then we're going to come over here and put in the x. Oh, I'm going to take it out. So the x goes through, and that's what we have, x plus 2. So that is going to be a linear function. Okay. Now, I put a couple things here that we can look at. We can say, okay, what if we say x equals 2? What does that become? So we put the x equals the 2 through, and that becomes 4 on that function. And then what if we say, okay, let's let x equal 5. What is that going to do? Okay, oh, I overshot there. Okay, so if x equals 5, then the function f of x equals 7. Okay, and then we can come here and look at that, and we can see that we do have that linear line. We have the first point we put in, and then the second point too. So they're all going to fall onto that. Okay, so that's kind of a different way of looking at things. Let's look at the next problem. We have y equals 3x minus 3. Okay, now f of x is one way of writing it, function of x. Y is another way of writing it, the same thing. So we're still looking at a linear function where we're going to put an x through, but we're going to put that with, what do we say, a minus 3. So I'm going to take this down here, bring this up, and minus 3. Let's get that out of the way. And then we're going to say 3x. And so we can go to the times, bring it up to 3, and put that in there. Okay. And then let's scrub all that out. And we'll put in an x. And what does that do? Oh, didn't want to take it there. Come on. There we go. It took it. So the equation becomes 3x minus 3. Now, what if we put in, say, put a 1 in for x? What does that become? Input, output, that becomes a 0. Okay. What about if we put in a 4 for x? Because we can pick whatever we want for x, and then we put it into the equation, and we'll get an output, which is the y value. And then if we do that, we go 3 times 4 is 12, minus 3 is 9. And so that becomes a 9. So that's the output. Now, we should be able to go and look at our graph, and sure enough, we have the graph with both of those points that we put in there. So that's kind of cool, huh? So we could always figure these things out manually, but this is kind of just a way of also looking at it and seeing how everything kind of lines up. The equation that you put in here, and then when you put the points in, where do they fall in, right? So kind of cool. So let's do one more. Let's get rid of that. Oh, bring that down. Bring that down. Okay. So the next one, I have f of x equals 1 minus 2x. right? That one looks a little different. What's going on there? Well, I mean, we like to have the x first, right? And if we have minus 2x, that is the same as 1 plus minus 2x, right? So you can actually swap those around and say that that is the equivalent of negative 2x plus 1 is the equivalent of 1 minus 2x. Okay, so let's do that. Let's put negative 2 up here, and we will find the plus x, just right here, the plus 1, I'm sorry, plus 1. I'll bring that up here, put that in there, and then we'll run the x in. And what kind of equation is that going to be? So that is the equivalent, right? Negative 2x plus 1. Same thing as 1 minus 2x. Okay, let's get rid of that. And then let's put in some values. So let's put in negative 2. We could put in whatever we want, really. And we put negative 2 in for x. Then the output is going to be 5, right? So negative 2 times negative 2 is 4. The negatives cancel each other out, plus the 1. That equals 5. All right. Now, if we bring in, let's just bring in a 2, see what that does, right? So 2, oh, doesn't want to take it. 2 times negative 2 is negative 4, plus 1 is negative 3. So that is the output there. And then if we look at the graph, sure enough, okay, we have those 2 points. Now you notice too that the graph, or the line on the graph, goes the opposite way. Before we were kind of dealing with positive slopes. Now we've got a negative slope. That's because of that negative 2. So rise over run, it's going to equal negative 2. So you can kind of visualize what that equation looks like, and then see it there too. So one more, okay, guys? Let's figure this out. Get this out of here. Scrub this. All right, next one. Y equals negative 1/3 x plus 3. There's nothing here that's a negative, or it's a 1/3. What does that mean? Well, remember, 1/3 is the same thing as dividing by 3. So on here, if I can get to it, there we go. Here's the dividing by 3. So we can take and put that up here too. That's the same thing as timesing something by 1/3 is the same thing as dividing it by 3. And then we're going to add a 3 also. Let's see, there we go. All right, now let's put that x in there, see what the equation is that we're going to get. There it is, 1/3 x plus 3. That's the equation we asked for. Okay, so now we can put in some values and see what we get. Let's put in a 3, see what that turns out to be. We can put any value we want in. A 3 divided by 3, or times 1/3, equals 1, plus 3 equals 4. So there we have that. That's kind of cool. And then if we put in, let's see, a 6, what is that going to do? 6 divided by 3 is 2, plus 3 is 5. So those are the two points that we have. And again, they are on our linear graph. And that's what we figured out. So pretty neat stuff. Hopefully that helps people kind of visualize what's happening. We're putting things in one side and they're coming out the other based on whatever functions we put in the mix. And so, yeah, hopefully that kind of helps people, and we will continue our journey on the math. Yeah. All right. Talk to you later, guys.